Hello everyone, welcome to our another video which is going to cover 7 testing principles. They are really important. Like in every other job, you have to follow certain principles in order to get your job done in a right way. Like in all other videos, we're going to talk about our subject and then you can check your knowledge. Let's go! These are those 7 principles, but before we start with them, let's just remind ourselves what is software testing for those who haven't watched our first video. Software testing is defined as an activity to check whether the actual results match the expected results and to ensure that the software system is defect-free. It involves execution of a software component or system component to evaluate one or more properties of interest. Software testing also helps to identify errors, gaps, or missing requirements in contrary to the actual requirements. And as we also said, it can be done manually or using automated tools. Okay, let's go with our principles. So these are the 7 principles of testing. Testing shows presence of defects. Exhaustive testing is impossible. Early testing, defect clustering, pesticide paradox, testing is context dependent, and absence of errors can be a fallacy. Okay, now we're going to talk about each. Every application or product is released into production after a sufficient amount of testing by different teams or passes through different phases like system testing, integration testing, user acceptance testing, and so on. And you can never see or hear from any of the testing teams that they have tested the software fully and that there is no defect in the software. Instead of that, every testing team confirms that the software meets all business requirements and it is functioning as per needs of the end user. So testing cannot prove that the software is error-free or defect-free. However, the objective of testing is to find more and more hidden defects using different techniques and methods. Testing can reveal undiscovered defects, and if no defects are found, that it doesn't mean that the software is defect-free. You cannot test forever. The product has to be delivered at some point of time when it's asked from the team. Sometimes, of course, this is not possible. Deadlines are sometimes broken if something unexpected occurs that cannot be solved right away. But then you negotiate with the client. Can it still be released with that problem? And to solve that problem in some of the next releases of the product. But that's not the subject of our team now. So let's give an example for this principle, testing shows presence of defects. Consider a banking application. This application is thoroughly tested, and multiple test phases and several rounds of testing are done. And after that, no defects are identified in the system. So you have your software, which is tested, and no defects so far found. And then, there might be a possibility that in the production environment, the actual user tries a functionality which is rarely used in the banking system, and the testers overlooked that functionality. Imagine yourself as an end user. So you're using that application, and you try to use it in a way that is either not covered by the code at all, or testers haven't tested that kind of flow that you used, and bam, you get the error. So to resume, testing shows presence of defects. It doesn't show the absence of defects, so it doesn't mean that there are no defects left in the system after the testing is done. Okay, let's move forward to our next principle. Exhaustive testing is impossible. Let's first see what is exhaustive testing. Exhaustive testing is the process of testing the functionality of the software where all possible inputs and their combinations are run along with different preconditions. So, it is not possible to test all the functionalities with all valid and invalid combinations of input data during the actual testing. Instead of this approach, testing of a few combinations is considered based on a priority using different techniques. Exhaustive testing would take unlimited efforts, and most of those efforts are ineffective. Also, the project timelines will not allow testing of so many number of combinations. So it's recommended to test input data using different methods like equivalence partitioning and boundary value analysis. And we're going to talk about that in some other video about those methods. Let's give an example. Suppose we have an input field, and that field accepts alphabet, special characters, and numbers from 0 to 1000 only. So, imagine how many combinations would appear for testing. It is not possible to test all the combinations for each input type. Let's say you just have numbers, so only from 1000. You're not gonna try all of those numbers. For example, if you try with number 5 and it doesn't work with number 5, it probably will not work with 6, 7, and so on. You're going to try those edge cases and maybe one example in somewhere in between. You will try -1, 0, 1000, 1001, and something between 0 and 1000. And that will be enough. Okay, so next principle is early testing. Testers need to get involved at an early stage of the software development life cycle. The defects during the requirement analysis phase or any documentation defects can be identified. The cost involved in fixing such defects is very less when compared to those that are found during the later stages of testing. Look at the image below, which shows how the cost of defect fixing gets increased as testing moves towards the live production. That image shows the cost required for fixing a defect, which is found during the requirement analysis, is less, and it goes on increasing as we move towards the testing and the maintenance phase. Now the question is, how early should the testing start? Once the requirements are finalized, the testers need to start testing. So the client comes and says, okay, this is what I want, and you dig in right away. Testing should be performed on those requirement documents, specifications, or any other type of documents so that if requirements are incorrectly defined, then it can be fixed immediately rather than fixing them in the development phase. Just take an example where some request doesn't really go along with another one, and developer takes those requirements and he turns it into a code. He makes the code to work like it is written in the requirements. It doesn't matter that they're not really compatible one with another. And then you start testing when the development is done. And then you realize, oh my God, this is not supposed to work like this. This is not logical. This thing does not go along with this thing. But then that code is already developed. And instead of realizing that at the first place, when you were analyzing the requirements, you realized it now when the code was already made. And then you have to report the bug, the developer needs to fix it, and so on. So you have to pay him double for the work he could have done correctly in the first place. Let's go on. Another principle, defect clustering. Before we even start talking about any kind of clustering, what is clustering at all? Well, it's kind of making groups of some units that have something in common. During testing, it may happen that most of the defects found are related to a smaller number of modules. A phenomenon that many testers have observed is that defects tend to cluster. There might be many reasons for this, like modules can be complex, they can be tricky, and okay, you wonder why, for example, 30% of the bugs are found in that part of the application or for that certain feature. Well, maybe because coding related to such modules can be complicated, can be tricky, or developer maybe made a mistake which might impact only a specific functionality or only a specific module. For example, if you take any application and you take a look at the login page. So there's not much you can do on login page. You can enter your credentials and try to log in like that. You can enter them correctly or incorrectly. You can try to log in without any credentials. So not much you can really do with them. And you certainly will not expect to find the most of the bugs there on the login page. You would expect them to appear in some more complex part of the application. So defect clustering means that in a project, a small number of a module can contain most of the defects. Pareto principle to software testing states that 80% of the software defects comes from 20% of the modules. While testing any software, testers mostly come across a situation like this, where the most defects found are related to some specific functionality, and the rest of the functionalities have a lower number of defects. Basically, what we're saying here that the defects are not distributed uniformly across the entire application. If testers look at 100 defects, then it will not be clear if there is any underlying meaning against those 100 defects. But if those 100 defects are categorized in some specific criteria, then it might be possible for the testers to understand that a large number of defects belongs a very few specific modules only. So testers, mostly when they figure that out, they concentrate on that area during the execution to find more defects. And of course, the other parts of the application should be also tested on a right way. Now let's move further to another principle, which you will probably learn right away because of the title, pesticide paradox. It reminds you of a bug. Okay. Pesticide paradox principle says that if the same set of test cases are executed again and again over the period of the time, then these set of test cases are not capable enough to identify new defects in the system. Just like the real bugs in the real life, in the nature, they can become resistant on some pesticide after it's being applied on them for a long time. It just doesn't kill them anymore. In order to overcome this pesticide paradox, the set of test cases needs to be regularly reviewed and revised. If it's required, a new set of test cases can be added, and existing test cases should be revised. After a few iterations of testing, quality of code gets improved and defect count starts dropping, as most of the defects are already fixed by development team, since developers are also cautious when coding a particular model where the testers count more defects. So, at one point of the time, most of the defects are already discovered and fixed so that no new defects are found in that module. So what can we do? We can, for example, as I already said, we can prepare new test cases to add to existing test cases. First, in the first phase, we covered deeply modules that were more error prone, and now we're going to add test cases for other modules. Total test case count then goes high, and it results in more effort and time required for execution. And that can probably have impact on the project timelines and on the project budget also. So to overcome this problem, the redundant test cases can be reviewed and maybe removed, but you have to be careful that you covered some flow in some other test case if you find some test case to be redundant and want to remove it. Okay, let's move forward to next principle. Testing is context dependent. There are several domains available in the market like insurance, banking, medical, travel, advertisement, and so on. And each domain has a number of applications. Also, for each domain, their applications have different requirements, have different functions, different testing purpose, different risks, techniques, and so on. So different domains are tested differently. So testing is purely based on the context of the domain or application. For example, testing a banking application is different than testing any e-commerce or advertising application. The risk that comes with each type of application is different. So there is no point using the same method, same technique, and testing type to test all types of applications. And when talking about the risk, imagine that you have undiscovered bug in the flight control system or in some software in some medical instrument in one hand, and on the other side you have an undiscovered bug in some software that is used for taking notes. I'm sure you can see the difference in risk here. So in the first case, we have human lives that are dependent on the quality of software, and on the other side, who cares about the notes? And also, when it comes to testing with mobile or web application, there should be also differences in testing approach. Okay, let's go to our last principle. Absence of errors may mean fallacy. If the software is tested fully, and if no defects are found before release, then we can say that the software is 99% defect-free. But what if this software is tested against the wrong requirements? In such cases, even finding defects and fixing them on the time wouldn't help, because testing is performed on the wrong requirements, which are not as per needs of the end user. For example, suppose the application is related to an e-commerce site, and the requirements for the shopping cart or shopping basket, whatever functionality, is wrongly interpreted and tested. So here, even finding more defects, it does not help to move the application into the next phase or in the production environment. So to solve this problem, we have to follow the principle that we already mentioned, and that is early testing. So if you have tested those requirements at the early stage when you got them, then you would maybe have more time to analyze them and to figure out what client needs. Okay, Now it's time to revise what we have learned. Testing shows presence of defects. It does not show the absence of defects, and that is when we talk about the testing shows presence of defects principle. It is impossible to run all possible tests and find all possible defects, which is connected to our exhaustive testing is impossible principle. Early testing saves time and money, which is of course connected to our early testing principle. Pareto principle, rule 80-20, 80% of the defects come from 20% of the modules, and the remaining 20% defects are distributed across the rest. 80% of the modules is of course connected to our defect clustering principle. Repeating same test cases for a long time may not discover a new defect, and that is when we talk about pesticide paradox principle. We use different testing approaches for different software domains, and that is of course connected with our context-dependent testing principle. And of course, sometimes 99% of the bug-free software can remain unusable if the wrong requirements are incorporated into the software. And that, of course, is connected to our last principle, absence of errors fallacy. Okay, guys, that will be all. And now you can check your knowledge. And if you pause the video for a while, on the next slide, you will find the answers. And again, thank you very much for listening, and like, share, and subscribe if you like it. And see you in the next video. Bye!